Advanced Functions. Grade 12. Units 6.1, 6.2, 6.3, 6.4, and 6.5. Trigonometric Functions. In this video, you will learn the radian measure and its relationship to the degree measure, how to use radian measure with trigonometric functions, how to make connections between trigonometric ratios and the graphs of the primary and reciprocal trigonometric functions. We will treat all variables as real numbers. Complex numbers are not covered in this video. Radian is a unit of measure of angles. 1 radian is defined as the angle subtended by an arc length equal to the radius. In our picture, the length of the arc, A, B, equals the radius, O, A, and O, B. The arc length created by an angle of 360 degrees is 2 pi r, the circumference of the circle. Each arc of length r corresponds to an angle of 1 radian. Therefore, 360 degrees equals 2 pi radians, and pi radians is 180 degrees. Dividing both sides by pi gives the value of 1 radian in degree measure, which is around 57.3 degrees. To convert the angle alpha degrees to radians, just multiply alpha by pi and divide by 180 degrees. To convert radians to degrees, do the opposite, divide by pi, and multiply by 180 degrees. Let's convert 320 degrees to radians and 3 radians to degrees. 320 degrees equal 320 degrees divided by 180 degrees and multiplied by pi. Simplify by dividing by the common factor of 20. 3 radians equal 3 times 180 degrees divided by pi, which makes 171.89 degrees. Now let's move on to our next topic, the unit circle, and special triangles. A unit circle is a circle of radius 1 centered at the origin 0, 0. If xy is a point on the unit circle's circumference, then the absolute value of x and the absolute value of y are the lengths of the legs of a right triangle, whose hypotenuse has length 1. Thus, by the Pythagorean theorem, x and y satisfy the equation, x squared plus y squared equals 1. Cosine and sine of angle theta may be defined on the unit circle as follows: if xy is a point on the unit circle, and if the ray from the origin 0, 0 to xy makes an angle theta from the positive x-axis, where counterclockwise turning is positive, then the cosine of theta equals x, the sine of theta equals y, and the equation x squared plus y squared equals 1 gives the relation. The squared cosine of theta plus the squared sine of theta equals 1. Now let's look at 2 right triangles that will help us calculate the sine and cosine of some angles. The first has angles of 30, 60 and 90 degrees. The second is an isosceles right triangle with angles of 45, 45, and 90 degrees. Reflect the first triangle in the x-axis. Triangle O-A-S is equilateral because it has 3 equal angles of 60 degrees. The length of its sides is 1. Therefore, y equals 0.5, and the sine of 30 degrees equals 0.5. Now substitute the value of the sine of 30 degrees and find the cosine of 30 degrees. The cosine and sine of 45 degrees are equal since the triangle OAB is an isosceles right triangle. Solve the following equation to find the sine and cosine of 45 degrees, 2x squared equals 1. X equals 1 divided by the square root of 2 or the square root of 2 divided by 2, and the cosine and sine of 45 degrees are equal to the square root of 2 divided by 2. Now let's go back to the 30 to 60 triangle and reflect it in the y equals x line. The triangle retains all its properties, however, the angle A-O-B is not 30 degrees anymore, but 60 degrees. X is the length of side AB now, and y is the length of side OB. Therefore, now the cosine of 60 degrees is 0.5, and the sine of 60 is the square root of 3 divided by 2. Reflect this triangle in the y-axis. Angle A-O-B is now 120 degrees. Sine is the length of the same side of the triangle, the square root of 3 divided by 2, the cosine becomes negative 0.5. Now reflect the last triangle in the y equals negative x line or the original triangle in the y-axis. The angle A-O B is 150 degrees, cosine is the negative square root of 3, divided by 2, and sine is 0.5. You can continue like this, and in each case, you will get the values of sine and cosine as the variation of positive or negative 1/2 and the square root of 3 divided by 2. In the same way, You can find sines and cosines for angles of 135, 225 and 315 degrees. If you have the values of the sine and cosine of an angle, you can calculate the secant, cosecant, tangent, and cotangent of that angle using the following formulas. Here are some examples. Determine the exact value of each trigonometric ratio. Solutions. A. Write 7 pi as 8 pi minus pi. 8 pi divided by 4 equals 2 pi, which is the period of the sine function. So you can drop 2 pi and the original expression becomes the sine of negative pi divided by 4. Since the sine function is an odd function, the latter can be written as a negative sine of pi divided by 4. The answer is negative square root of 2 divided 2. B. Write 2 pi as 3 pi minus pi. 3 pi divided by 3 equals pi, so you get the cosine of pi minus pi divided by 3, which is equal to the negative cosine of pi divided by 3. The answer is negative 0.5. Circle A has a radius of 15 centimeters and a central angle of pi divided by 6 radians. Circle B has a radius of 17 centimeters and a central angle of pi divided by 7 radians, and Circle C has a radius of 14 centimeters and a central angle of pi divided by 5 radians. Put the circles in order, from smallest to largest, based on the lengths of the arcs subtending the central angles. Solution. To find the length of the arc, multiply the given angle in radians by the length of the radius. The arc length of circle A is 525 pi divided by 210. The arc length of circle B is 510 pi divided by 210. The arc length of circle C is 588 pi divided by 210. The circles in order, from smallest to largest, based on the length of the arcs subtending the central angles are B, A, and then C. The members of a high school basketball team are driving from Calgary to Vancouver, which is a distance of 675 kilometers. Each tire on their van has a radius of 32 centimeters. If the team members drive at a constant speed and cover the distance from Calgary to Vancouver in 6 hours 45 minutes, what is the angular velocity, in radians second, of each tire during the drive? Solution. Convert the distance into centimeters, and the time into seconds, and then take the distance from Calgary to Vancouver as the length of the arc on the wheels of the van and calculate the central angle corresponding to this arc in radians. Then divide the resulting value in radians by the time in seconds. To calculate the central angle, divide the distance by 32 centimeters, the radius of the tires. The final answer is 86.81 radians per second. A clock is showing the time as exactly 3 p.m. and 25 seconds. Because a full minute has not passed since 3 o'clock, the hour hand is pointing directly at the 3 and the minute hand is pointing directly at the 12. If the tip of the second hand is directly below the tip of the hour hand, and if the length of the second hand is 9 centimeters, what is the length of the hour hand? Solution. The central angle between the hour hand pointing directly at 3 and the second hand pointing directly at 25 is 60 degrees. Because the tip of the second hand is directly below the tip of the hour hand, the triangle with the vertices at the center of the clock and at the tips of the hands is a right triangle. The second hand is the hypotenuse of this triangle, the hour hand is the base. To calculate the length of the hour hand, multiply the length of the second hand by the cosine of the angle between them. Prove the following equation. Solution. Move the expression from right to left. Simplify the equation. Move 1 to the right side. The equation you have is true for any alpha angle. The terminal arm of alpha is in the fourth quadrant. If the cotangent alpha is equal to the negative square root of 3, calculate the sine alpha cotangent alpha minus the squared cosine alpha. Solution. Since the terminal arm of alpha is in the fourth quadrant and the cotangent alpha is equal to the negative square root of 3, the angle is negative pi divided by 6 plus 2 pi k, where k is a whole number. Therefore, sine alpha is equal to the negative 1/2, and cosine is equal to the square root of 3 divided by 2. Substitute the values and simplify the expression. Now let's move on to our last topic, graphs, and transformation of trigonometric functions. Here you can see the graphs of four trigonometric functions: y equals sine of x, y equals cosine of x, y equals tangent of x, and y equals cotangent of x. The sine and cosine functions have the same period of 2 pi, amplitude of 1, maximum of 1, and minimum of -1. The tangent and cotangent functions have the same period of pi. Vertical asymptotes of the tangent function are at pi divided by 2 plus pi k, where k is an integer. Vertical asymptotes of the cotangent function are at pi k, where k is an integer. The graphs of functions of the form f of x equals a, sine of k times, x minus d, plus c and f of x equals a, cosine of k times, x minus d, plus c, are transformations of the parent function f of x equals sine of x and f of x equals cosine of x, respectively. Each point xy of the parent function transforms into the point x divided by k, plus d, ay plus c. Sketch a graph for x greater than or equal to 0 and less than or equal to 2 pi for the function f of x equals 1/2 of the cosine of x divided by 2 minus pi divided by 2, minus 3. Write x divided by 2 minus pi divided by 2 as 1/2 of x minus pi. Create a table of the graph points of the parent function and the points to which they were transformed. Plot the key points of the transformed function and draw smooth curves through them.